Close your eyes. Where are you? You feel like you're behind your eyes, inside your head, looking out. That's where your mind is, right inside your skull. Feynman discovered this is completely wrong. Your mind isn't in your head. It's not even in your body. And once you understand where it actually is, your entire sense of self changes forever. Los Angeles, 1954. Richard Feynman walked into a laboratory at UCLA where a strange device had been constructed. A soundproof, light-proof tank filled with salt water heated precisely to body temperature. The concept was elegantly simple. Eliminate every incoming signal. No light, no sound, no tactile sensation. The water supports you so completely that gravity becomes imperceptible. No temperature differential whatsoever. The water matches your skin exactly. Nothing. Float in absolute darkness and observe what happens to consciousness when you remove everything feeding it. Feynman wasn't pursuing spiritual enlightenment. He'd encountered reports of sensory deprivation, people describing hallucinations, sensations of leaving their bodies, radically altered awareness. He wanted direct experience, not secondhand testimony. Not because he subscribed to mystical interpretations, but because he wanted to observe empirically what his own brain would generate when starved of external input. So he climbed into the tank. The lid sealed shut. Darkness, silence, weightlessness. Initially, nothing unusual registered. He could locate his body. He knew where his limbs were positioned. Everything felt normal. But somewhere around the 20-minute threshold, something genuinely strange began unfolding. His sense of his body's position in space started dissolving. One arm seemed to occupy a location it couldn't actually occupy. Then he lost the arm entirely. Not the physical arm, but any felt sense of where it was. Then he couldn't recall whether he possessed arms at all. The boundary he'd always taken for granted, where his body ended and the surrounding water began, became ambiguous, then permeable, then simply absent. For a suspended moment, he had no body. Or more precisely, he couldn't locate his body. Consciousness persisted. Thinking continued. But spatial reference had evaporated. The sense of being here rather than there gone. It terrified him initially. Then the terror transformed into something far more useful. Fascination. Because what had just dissolved under controlled conditions was something he'd assumed was bedrock. The feeling of being physically located somewhere. And bedrock, it turned out, was construction. Something the brain assembles from incoming data rather than something intrinsic to awareness itself. Remove the data and the assembly collapses. Right now, where do you feel yourself to be? Most people would say something like, behind my eyes and my skull, looking outward through my eyes as though through windows. But consider what that description actually implies and where the physics actually takes you. Your eyes aren't windows, they're transducers. Photons strike the retinal surface, triggering electrochemical cascades in receptor cells, which transmit electrical signals along the optic nerve toward the back of your skull. Visual processing happens in the occipital cortex, which sits at the rear of your brain, as far from your eyes as your skull allows. That's where visual information actually gets processed, not in front but behind. So why does subjective experience place you behind your eyes rather than behind your head? Because your brain builds a working model of the external world, and within that model, it needs to position an observer, a reference point, a coordinate origin for the entire spatial map being constructed. It places that origin at the location of the primary sensory inputs. Your eyes point forward, so the model positions you as forward-facing, looking outward. But this placement is a modeling decision, not a physical fact. There's no actual observer stationed behind your eyes. There's no miniature experiencer inside your skull examining projected imagery. That concept immediately generates an infinite regress. The miniature observer would require its own internal observer, which would require another, endlessly. What's actually happening is that your brain processes sensory data, constructs a spatial model, and generates within that model the felt sense of a perspective. That sense of perspective is itself a constructed feature of the model, not a window onto reality, but a feature of the simulation. Here's how easily that construction can be hijacked. In a classic experiment known as the rubber hand illusion, you sit at a table with your actual hand concealed from view. A realistic artificial hand is positioned in your visual field where your real hand would normally appear. A researcher then uses two brushes simultaneously. one stroking your hidden real hand, one stroking the visible artificial hand, maintaining identical rhythm and pressure. Within a few minutes, something that seems like it shouldn't happen happens. You begin attributing sensation to the artificial hand. You feel touch there where the rubber is. When someone moves toward the artificial hand with something sharp, you recoil defensively. Your brain has adopted the rubber hand as part of your body. The mechanism is straightforward. Your brain is constantly cross-referencing sensory streams, looking for correlations that indicate what belongs to what. Visual information says this object in my field of view is being stroked. Tactile information says something in my field is being stroked. The timing aligns precisely. Your brain draws the only reasonable inference available from that correlation. This visible hand is my hand. The fact that the hand is synthetic, the fact that it occupies a slightly different spatial position than your actual hand, these discrepancies don't override the correlation signal. The inference stands, which demonstrates that body ownership, your brain's determination of which physical objects constitute you, is not a fixed biological truth. It's a continuously updated probabilistic inference based on sensory correlation. It can be redirected. The implications of that redirectability extend much further than rubber hands. In 2007, neuroscientist Henrik Eriksson designed an experiment that physically displaced people's experienced location from their actual location. Participants lay in a brain scanner wearing virtual reality headsets. The headsets showed them live footage from a camera positioned 6 feet behind and above their physical body, so they could see themselves lying in the scanner from an external vantage point. Then a researcher took two objects. One touched the participant's actual chest, which they couldn't see. The other touched the empty air just below the camera, below the external view of their body at the same moment, in the same rhythm. Visual information said, something is being touched here at this external location, 6 feet behind me. Tactile information said, something is touching my chest. The correlation was tight, the timing identical. Within seconds, participants reported that they felt as though their experienced location had migrated. They felt they were positioned where the camera was, floating 6 feet behind their physical body, observing themselves from outside. This wasn't metaphor or suggestion. Brain scanning confirmed it. The temporoparietal junction, the neural region responsible for processing self-location, showed activation patterns consistent with the person's experienced position, being at the camera location rather than at the body location. A laboratory-induced out-of-body experience generated by nothing more exotic than correlated sensory timing. The conclusion that emerges from these experiments is uncomfortable. If you've taken for granted that you're reliably located where your body is, your brain's best guess about where you are can be experimentally manipulated. There's no you that's inherently tethered to your skull. There's a brain generating an inference about where to position the observer within its spatial model, and that inference responds to evidence. Alter the evidence and the inference updates accordingly. When Feynman surfaced from the isolation tank in 1954, his transformation wasn't spiritual, it was conceptual. What he'd experienced had clarified something about the relationship between physical brain and conscious experience that scientific vocabulary hadn't yet articulated cleanly. The brain is a physical object. It has mass, location, spatial coordinates. It sits inside a skull which occupies a particular position in space. None of that is mysterious. But consciousness, the subjective quality of experience, the felt sense of being aware, what philosophers call qualia, that isn't an object. It's an activity, a process. And processes have a different relationship to location than objects do. Consider combustion. You can say that combustion is occurring in this particular fire at these particular coordinates, but combustion itself isn't located at those coordinates in the way the fuel is located there. Combustion is what's happening. It's the process, the activity, the event. You can point to where it's occurring, but the process isn't a thing sitting in that location. Feynman came to understand consciousness similarly. You can point to the brain in which consciousness is occurring, but consciousness itself isn't located in the brain the way neurons are located in the brain. It's what the neurons are doing. It's the activity, not the substrate. This realization extends further than the skull. Contemporary cognitive science has developed what researchers call the extended mind hypothesis, the proposal that cognitive processes, memory, reasoning, problem-solving don't terminate at the boundary of the skull, they extend into the environment. When you record information in a notebook, that notebook becomes functionally part of your memory system. The information is stored externally, but it participates in your cognitive processes in the same functional way internal memory does. When you use a calculator, the computation occurs outside your brain, but constitutes part of your reasoning process. When your phone navigates you through unfamiliar territory, GPS processing substitutes for internal spatial reasoning. Feynman understood this in practice before the theoretical framework existed. He was famous for refusing to engage with difficult problems without paper. Not because the mathematics exceeded his mental capacity, it frequently didn't, but because externalizing the work onto paper transformed the problem into something manipulable in ways that purely internal processing couldn't achieve. He would say that the drawings and equations weren't representations of his thoughts. They were his thoughts occurring partially outside his skull. His mind extended into whatever surface he was working on. The boundary of cognition was wherever he was currently thinking, not wherever his neurons happened to be located. Now consider the binding problem, which troubled Feynman for years and remains one of the deepest unresolved questions in neuroscience. Your brain processes different dimensions of perception in anatomically distinct regions. Color processing occurs in one area, motion detection in another, shape recognition in yet another, auditory processing in a completely separate region. When you observe a red ball bouncing across a floor and producing sound, your brain is simultaneously handling redness in one place, spherical shape in another, downward and upward motion in a third, and the impact sound in a fourth. These processes occur in genuinely different physical locations within your skull. They are not happening in the same place, yet your experience is unified. You don't perceive disparate fragments. Color here, shape there, motion elsewhere, sound separately. You perceive a single coherent event, a red sphere bouncing and making noise. Something integrates these distributed processes into unified experience. But neuroscience has found no integration center, no place in the brain where all the streams converge into a single processed output, no Cartesian theater where the finished experience gets displayed. The leading hypothesis involves temporal synchronization, neurons in different regions firing at correlated frequencies which the brain treats as belonging to the same object. But this explains correlation, not unification. It tells us how different neural processes get tagged as related. It doesn't explain why they feel like one thing. What this means for the question of where your mind is located. If there's no point of convergence, if perception is fundamentally distributed across your brain, then your mind isn't anywhere in particular within your skull. It's spread across the entire active system. And the unity you experience, the feeling of being one conscious entity rather than a committee of parallel processes, is itself a constructed feature, a property of the pattern rather than evidence of a central location. Split brain research makes this undeniable. Surgeons treating severe epilepsy have severed the corpus callosum, the thick fiber bundle connecting the left and right cerebral hemispheres, to prevent seizures from propagating between hemispheres. The surgery works for its intended purpose, but it produces a secondary effect that raises deeply unsettling questions about personal identity. The two hemispheres, no longer exchanging information, begin operating as independent cognitive systems within a single skull. The left hemisphere controls the right side of the body and handles language. The right hemisphere controls the left side of the body and is largely nonverbal. Present a split-brain patient with a word in their left visual field, information routed to the right hemisphere, and they cannot tell you what they saw because the verbal left hemisphere never received the information. But they can reach out with their left hand and select the corresponding object from a group, demonstrating that the right hemisphere perceived the word and understood it. Two separate processing systems, each with its own knowledge, responding differently to the same world. In one documented case, a patient's two hands worked against each other, one attempting to button a shirt while the other unbuttoned it. Two intentions, two behavioral programs operating simultaneously within a body, their owners both claimed as singular. What does personal identity mean in that context? Is there one person there or two? The patients report feeling normal. The experiments showed distinct preferences, different knowledge bases, sometimes conflicting intentions. Feynman found this deeply challenging to his intuitions about selfhood. If cutting neural connections produces what functions like two minds, then minds aren't unified substances, they're unified patterns, and patterns can be divided. So where is your mind? The honest answer is that the question contains a hidden assumption that makes it unanswerable in its usual form. The question assumes that your mind is a thing, an object that occupies a location. Remove that assumption and a different picture emerges. Your brain is a physical object and it exists at a specific location. Your mind is what that physical object does, the activity, the process, the pattern of coordinated activity across billions of neurons. Processes don't have locations in the way objects do. Asking where your mind is located is like asking where Tuesday is located. The question's grammar doesn't match the category of thing being asked about. The feeling of being somewhere, of existing behind your eyes in a particular spot in space, that feeling is a product of consciousness, not a property of consciousness. It's something your brain generates as part of its model, useful for navigating physical space, essential for coordinating action, but not a fundamental metaphysical fact about the nature of awareness. When sensory input is removed, as Feynman discovered, that feeling dissolves, because the feeling was built from input. When the input disappears, the construction that depended on it disappears too. In his final years facing terminal cancer, Feynman turned his characteristic clarity onto the question of what ending would actually mean. He wrote to a friend, "When my brain stops, I stop. There's no continuation, no location to which something migrates. The pattern that constitutes me dissolves." But in the same correspondence, he expressed something that resisted his usual deflation, the sheer improbability of the situation. Atoms arranged into structures that experience their own existence, matter that develops an interior perspective on itself, physical processes that generate the felt quality of being aware. How does matter become aware of itself? How does electrochemical activity give rise to subjective experience? Why is there something it's like to be a brain rather than nothing? These questions, what philosophers call the hard problem of consciousness, remain genuinely unsolved. We can map neural correlates of conscious states. We can describe what the brain does with remarkable precision. We cannot explain why any of that doing is accompanied by experience rather than occurring in darkness. Feynman was comfortable with that incompleteness. It's a real problem, he'd say, a scientific problem, not evidence of the supernatural, but evidence of the depth of what physics has yet to explain. What he was certain about: consciousness has no location, not because it's supernatural, precisely because it isn't. It's a process, distributed and extended, emerging from physical activity, but not occupying space the way physical objects occupy space. You are not a ghost operating a biological machine. You are the machine's activity. You are the process itself. And processes don't sit anywhere. They just happen. Where is your mind, really? Not behind your eyes? That's a model feature, not a metaphysical address, not confined to your skull. It extends into your body, your tools, your environment, and your relationships. Not localized anywhere within your brain. It's distributed across whatever neural activity is currently constituting your awareness. Your mind is not in a place, it's an event, a temporary, extraordinarily complex pattern of organized matter that has somehow become aware of its own organization. That's Feynman's actual discovery. Not that your mind is somewhere unexpected, but that location is the wrong category entirely. And once you genuinely understand that, the question you thought you were asking transforms into something far stranger and far more interesting than you originally imagined.